Good day, everyone, and welcome to this Lightbend interactive demo for August 27th, 2020, titled Akka Cluster Nodes Under Attack, Visualized. My name is Oliver White, Chief Storyteller and MC at Lightbend, and joining me today is my colleague and Akka best buddy, Hugh McKee. Hugh is our developer advocate for Akka Platform, as well as an O'Reilly author, conference speaker, at least in another life, and former aeronautics engineer. If you've joined our webinars in the past, you'll notice that today's session departs from our normal style. As we explained on the sign-up page for this, you are welcome to perform the setup and demo along with Hugh if you like, and we'll be taking some regular stops to discuss specifics and answer questions. The reason we're here is that, as you probably know, distributed applications running on clusters can come under attack at any time, and for many reasons. What do you do when this happens? How do you safely run clusters of networked computers where nodes fail regularly? In this hands-on session with Hugh, you'll get to see the first-hand dynamics behind failure and recovery with Akka Cluster, especially looking at the difference between do-it-yourself recovery and automated recovery with Splitbrain Resolver. We'll start off by briefly going through the Akka Cluster demo project and the browser dashboard. This will allow folks that are interested in getting their project started up now to do that. We'll continue by looking at what happens when things go wrong without automated recovery and the steps needed to get your cluster back to a healthy state. Then we'll look at how Splitbrain Resolver works to automate the recovery mechanisms behind node failures, network partitions, and split-brain scenarios. This automated recovery aspect will get your Akka applications back to the state where orchestration technologies like Kubernetes can restart pods and get the app running back at its original state. Lastly, we'll drill into some more questions and suggestions for cluster manipulation. We'll test some different scenarios, and we'll bring some more questions forward to Hugh about Akka Cluster and Splitbrain Resolver. Okay, some final remarks. As always, today's webinar is made possible only by Lightbend's hundreds of happy customers that benefit from expert support, technology enhancements, observability, and monitoring as part of our subscription, such as our customer Bright House Financial. They're one of the largest providers of annuities and life insurance in the United States, and they have two available positions for lead principal software engineer with extensive experience in Akka, Scala, and Java. You can find out more by visiting jobs.brighthousefinancial.com and searching under the keyword Akka. This webinar is being recorded and will be made available for replay next week. If you have questions for Hugh, as you know, add them to the GoToWebinar control panel, and we'll see if we can get them get around to them in the Q&A part of today's session. If you are an existing subscriber, then you should be aware that you can reach out directly to our expert engineers through the customer portal, where you can ask any additional technical questions, what-ifs, how-tos, and best practices. Okay, that's all from me. Let's now hand it over to Hugh McKee.
Thanks. Now I'm totally freaked out. All my windows are all screwed up, but we'll get through it. So yeah, as you were mentioning, we're going to be reviewing how the Splitbrain Resolver works by showing things happening without it and then with it, that type of thing. If you're following along, what you need is pretty straightforward. You just need Git and Java and Maven, and then you can clone this repo from GitHub. It's at McKeeH3, which is my GitHub user, and akka-type-java-cluster-spr.git. So that's what I'm going to do. So if I can find all my windows, sorry for scrolling like crazy here. All right, so I'm going to, the first thing I'm going to do is clone this project into my temp directory, and then I'm going to cd into the directory. And the first thing I'm going to do, though, is edit the application conf file, which is a configuration for Akka using type safe configuration, that type of thing. And I want to comment out the line that has the one configuration setting that's needed for setting up SPR, which is this Downing provider class. It's on line 15 here, and it's in the Akka's documentation. If you do a search on Splitbrain Resolver, one of the very first sections in the documentation talks about this configuration setting. So what I'm going to do is just comment out this line for now. And then I'm going to build the project. It's just a Maven clean package project. It's just a Java Maven project.
So Hugh, just to confirm, you're commenting out the Splitbrain Resolver part of the configuration for this demo, but folks following along with us don't necessarily have to do that at this time.
They don't have to. I mean, if they, to do the steps that I'm going to be doing, where we're going to cause a network partition and we're going to manually recover from it, if they have SBR enabled, it's going to do it for you before you can really
Right.
do
Okay.
anything.
That's clear. Thank you.
And I know what I forgot to mention, unfortunately, this doesn't work on Windows. It works on Mac, it works on Linux. I tried to get it to work on Windows. And the issue that I had was, in order to do this demo, I run a cluster of n number of nodes, and I'll start up the cluster now. And some of the nodes run on localhost 1, and some of the nodes run on localhost 2, which in fact I need to re-enable everything. So getting ahead of myself. So there's in this project, there are a bunch of scripts which make it easier for us to run things. And there's a main script, and it's just called Akka. And if you just type /Akka in the project directory, it'll give you a little help, and it shows you 3 sets of commands. So there's a set of commands for starting and stopping things at the cluster level, like you can start a cluster with n number of nodes from 1 to 9. This demo is a bit contrived. It does a bunch of port manipulations and things like that, so it's really limited to 9. There's a set of node-specific commands. So here we can start and stop specific nodes instead of the entire cluster. So the idea is you would start up a cluster, and then you can start playing around with nodes in the cluster using these node commands. And then the ones we're going to be using a lot in this demo, these Akka net commands, these are really here. I added these to enable the whole Splitbrain Resolver, kind of simulate a network partition. And I'll be explaining a bit about what that is, but we'll do it visually. But first, I need to do a couple of these setup commands, which is the Akka net enable. So the enable, it's for the Mac only. I'm on a Mac, so it enables packet filtering, because we're going to be introducing a network rule that stops traffic between localhost 1 and 2. So I need to enable that. My sudo password. Okay, and then the other command I need to do is also do this localhost. It's localhost 2, and this is sets up the second localhost in the network. And then that's it. So now I should be able to start the cluster, which is just /Akka cluster start, and by default it'll start up 9 nodes. And then I can do a status check. This is just a command level thing to see if the cluster is coming up. So we get some JSON back, we've got a cluster, and then there's a command to bring up the dashboard, which is Akka Cluster dashboard. But before I do that, let me, sorry for this. I want to move this window over.
Okay, you've been rattled a bit by this ridiculous experience. So we're all good. The feedback from the audience is, haha, yeah, this happened to me recently too. So
yeah, welcome to the world of high tech, right? We this is our life, our lot in life, right? So now I'm going to bring up the dashboard, and the dashboard just it's a web page. This dashboard, all the source code, just some little bit HTML and a bit of JavaScript, something I wrote for this demo project, is all included in this project, so you can run it yourself. And some of you may have seen previous webinars and videos that we've done in this dashboard. But basically what we're doing is we're visualizing this running cluster. So just real quick, and I've done other videos that go into a lot of detail on how this dashboard and the node life cycles in Akka and things like that. So if you're really interested, that you can find those videos on YouTube. But just as a quick review, on the left-hand side, you can see this kind of this array of 3 by 3, and this is the 9 nodes running in the cluster. And it's kind of a repeated view. They all look the same, where there's 9 these 9 little green boxes, say under all the cluster nodes under port 2551. And what this is showing, though, is that this web page is pinging each individual node in the cluster, and it's asking that node, like, what does the cluster look like to you? So they all are in agreement right now that the cluster has 9 nodes running, so they all share the same view. But what we'll see as we kind of go through this is that when the state of nodes in the cluster changes, they don't all happen at once, because we're running on 9 JVMs here. And normally an Akka cluster is running on 9 virtual machines or 9 Kubernetes pods or whatever, whatever environment we're running in. And all these nodes are talking to each other across the network. So, but the trick of this dashboard is that it's pinging about every couple hundred milliseconds information. It's harvesting information from each individual node, and it's showing that. So right now everything's green, is showing that all the nodes are up. So what I want to do is I'm going to do a partition, which is this AkkaNet partition on or off. So I'm going to do a on, which should turn on the partition. And what we should see pretty quickly, if it all works, there we go, perfect, is that we've got some red. But if you look really closely, and this was the main reason why I wanted to do this dashboard, is to be able to visually actually see a network partition. And what you can see is that where the partition is split, the top 5 nodes, nodes 1, 2, 3, 4, 5, they all look the same. They see each other. They see that the 5 top nodes are green. The bottom 4 nodes are red. However, if you start at node 2556, 7, 8, 9, they only see each other, the bottom 4 nodes, but they can't see the top 5 nodes. So this is a classic network partition. It could be, for example, if we're running in some kind of a data center and maybe a switch breaks, and it just kind of cuts off a bunch of nodes that we're running in the Akka cluster. They can still talk to each other, but they can't talk to the nodes that are on the other side of the partition. And this is what visually we're seeing here, is that the top 5 can see each other, but they can't see the bottom 4. The bottom 4 can see each other, but they can't see the top 5.
Hey, Hugh.
Yeah.
So there was a question that came in that's kind of related. So we're not looking at a multiple node failure here, where 4 nodes out of 9 go down and all 9 nodes are seeing the same thing. What we're actually seeing is there's been a brick wall, let's say, put between 5 and 4 nodes, and both of them are unaware that they can't see the other, but both of them are still operating, right?
Yes, exactly. Excellent question. And that it is the situation where all 9 nodes are still running. And normally when Akka nodes are running, they're all gossiping with each other across the network. It's like all of us in this call pretend like each one of us is a node. We're, in order for us to know if you're still there, if the only thing we can do is talk to each other, audio, we'd be just sitting here just going, hey, Oliver, you there? Hey, JP, you're there. And if I don't hear back from him, it's like, oh, he's unreachable. He's not responding to me. Say you guys can't talk to me and I can't talk to you, but you two can talk to each other. But me and somebody listening in, we can still talk to each other, but we can't talk to Oliver and JP, for example. So we're all alive, but our communication channel is split. And this is, really think about it and kind of wrap your head around what's happening. It's really things like, how do you fix this? Because The 5 nodes on the top can talk to each other, but they can't talk to the 4 nodes on the bottom. The 5 nodes on the top, all they know is they can't talk to the 4 nodes on the bottom. They don't know if they fell off a cliff, if the data center they were in blew up, if it's just the network is broken. They have no way to know because they're completely cut off. And this is the same thing for the 4 nodes in the bottom. All they know is they're up, but they don't know what happened to the ones that are on the other side of the network partition. So a decision has to be made. Now, we're doing it manually right now. So, you know, the strategy that we'll be showing when we enable SBR, the most common strategy is it's called keep majority, where you look at the situation and you go, all right, where's the majority of nodes running? And obviously here it's the 5 nodes on the top, and it's not the 4 nodes on the bottom. However, the trick is that the 4 nodes on the bottom are still running. So it is really split. There's a split brain here. Both sides of the partition have to act on their own without being able to talk across the partition and make a decision about what we should do. So,
hey, Hugh,
yeah.
Sorry, just a quick other question. So what's the main issue here? What's the negative result that comes when we have a split brain scenario and the cluster continues performing? What's the biggest problem that occurs?
Yeah, another really, really good question. Yeah, you guys hitting it right on, Mark. Yeah. With the Akka cluster, its most common use case, fundamental use case, is it's a delegation and distribution of work. And one of the really unique features of Akka is that, you know, fundamentally you have actors. Actors have state. So you have actors that are, each individual actor instance is handling, say, a particular thing like a shopping cart. Like, you know, there's an actor for my shopping cart, there's another actor for your shopping cart. And there only can be one instance of that actor for my shopping cart anywhere in the cluster. So all the traffic for my shopping cart is routed to my actor. All the traffic for your shopping cart is routed to your actor. This is one of the real magic kind of cool things that Akka does. I mean, as just an example, it's just, you know, the routing the messages. So there's this whole strategy for distributing the work across the cluster. But now it's like, you know, say my shopping cart is on the bottom, somewhere on the bottom 4. Your shopping cart's on the top 5. And the top 5 clusters look and go, oh, I just got a request for Hugh's shopping cart. What am I going to do? You know, and when the network's broke, or the cluster is in this state as it is right now, where there's nodes that are unreachable, it really can't do anything because it can't distribute work anymore. And it knows that some work that was supposed to be, when everything was running, sent to one of the bottom 4 nodes, can't be sent to the bottom 4 nodes. It can't make a decision about how do I readjust that, because what we want to avoid is having the same, you know, 2 instances of the same actor on both sides of the cluster, both trying to change my shopping cart at the same time, because of, you know, concurrency issues, you know, overlapping updates and things like that. This is a stateful system, so it's this, you know, it's a distributed work type of system. Unique instances of state being managed in specific locations, you know, given the current topology of the cluster. And when the cluster breaks like this, that's disrupted.
All right, great, thanks.
So what I'm gonna do is I'm gonna manually down the 4 nodes on the bottom. You know, so they're the minority. There's 4 of them and there's 5 up above. So I'm the operator in this case. I'm the human that's responsible for fixing this. So I'm going to down the 4 nodes, but the downing is kind of interesting. In fact, let me. So the down is, there's a down command, you know, Akka node down, but then there's this via. So what the via 1 is, what that's saying is that it's going to send the down command, or actually commands, to node 1. And the commands are going to be sent as, say, down 6, down 7, down 8, and down 9. So when I do this command, if I go back to the dashboard, what we'll see is the top 5 nodes are now happy that there's no red anymore. So what that means is that as far as this cluster is concerned of 5 nodes, the cluster is in a good state. There's no nodes that are unreachable. So now it's free to redistribute the work that used to be distributed to the 4 bottom nodes to the top 5 nodes. But while it was in that state where there were red unreachable nodes, the cluster couldn't redistribute the work because it didn't know. Maybe the partition will go away and all the bottom 4 nodes will suddenly come back to life. So anyways, that's what the down command did. But I'm not done yet because the bottom 4 nodes are still running. So I got to down those. But in this case, I need to do it via one of the nodes in the bottom 4. So I say via node 6, A down 6, 7, 8, and 9. So I'm going to do that. And we go back to there. And you can see, just for a moment, you can see that they've gone into a down state. And then now they're gone. So I manually basically did the job that the Splitbrain Resolver does. So now,
Hugh, let me just see if I'm caught up here. If you could go back to the dashboard when you're done real quick.
Yep.
So what we saw was a 9-node cluster that had a split brain scenario, a network partition that caused a split brain scenario where 2 sides of the cluster were continuing to operate but without awareness, which can cause tons of data inconsistencies and so on. Then, so the first step is you told the majority side of the cluster to down, from its perspective, down the minority side of the cluster of 4.
right.
So the cluster of, now we've got a happy cluster of 5,
Right.
when we had 9 originally. And then the other side of it was that you had to tell the split side, the minority side, to also down itself because it shouldn't be running.
Right. And
so now we're at a state where we've got 5 out of 9 nodes and they're happy. So we're continuing to receive messages and so on.
Right.
But we don't have our full cluster back yet. Am I following right? Great.
Yep. And
Cool.
When I downed the 4 bottom ones, that also stopped those nodes.
Right.
So when a running node gets a down request, it will cause it to do an orderly shutdown and terminate the JVM. So now they were green, showing the 5 top red. We downed them. They showed that kind of purplish color for a moment, and then they went away. And then what I did was I turned the partition off, which is just kind of doing a local network command to turn off that rule. And I should be able to start up nodes 6, 7, 8, 9 again. Say whatever the issue was, we resolved it and they're fixed. And then we start up the nodes. And you can kind of see it, things were happening across the dashboard, not all at the same time. And that's what I was talking about earlier, that this dashboard is looking at each individual node, asking what does the network or what does the cluster look like to you? So for a moment there, while they were coming up and coming to life, you were seeing a different picture. So now we're back to all 9 up and running. And I manually started up the 4 nodes at the bottom. And I did that using that Akka node start 6, 7, 8, 9. These scripts are just
So we've got a bunch of questions coming in. I'm getting a little freaked out that I'm not going to be able to actually field them properly, but a lot of them are along the lines of, okay, while we were stuck in that split brain scenario, what was happening to messages? Were they coming in? Was Akka Cluster saying, hey, we're detecting that there's a problem in our cluster. We're going to halt the processing of messages? Were messages that were on a node? If actor message, for example, was on a particular node and that node went into the red, what happened to that message? So kind of, let's say, recovering the activity that was going on in the cluster at the time.
So, yeah, good question. And the answer is that some messages could still be coming in, because maybe the however messages are generated, that wasn't disrupted by this network issue. Say this was this thing is, say it's not a microservice and it was receiving HTTP from some load balancer or something. So those messages could still come in, and if those actors were already alive, those that are the intended targets of those messages, the messages could still be processed. But the thing that stops is any kind of cluster decisions. Like if an actor needs to be started, and it has to be started, of course, on one of the nodes on the other side of partition. Of course, that's not going to work. But new actors can't be started, and rebalancing actors and so on can't be done, because like when we had the 5 nodes on top realized they couldn't talk to the 4 nodes on the bottom, there was a ton of work that was happening on those 4 nodes that the top 5 nodes would like to take on, and it would do it if the cluster wasn't in a state where one or more nodes were unreachable. So Akka will not make any decisions when the cluster is in that state. It will not make any kind of reallocation, rebalancing kind of decision. So some limited amount of work can still happen, but no kind of cluster level decisions are going to be made.
So it basically takes away the advantages that Akka Cluster brings to your Akka app. So it's not like everything crashes and you're out of business. It's that throughput goes way down.
Some messages can't be, and some messages can't be processed because
right. So we're not crashed, but we are hitting a very limited state, and this is precisely why we use Akka Cluster, so that we have that intelligence in our clusters, right?
Right.
All right.
So some clients say, if they're humans that are interacting with this system, some humans would not even see a problem potentially, but others would see, or whatever, however your app would handle the some kind of a serious issue.
Mm-hmm.
But they wouldn't be able to do their work.
Okay.
So,
well, folks, we are, Hugh, I believe we're about to get into the, let's see what happens when Splitbrain Resolver is part of the story here.
Right.
And while you do that, I'm going to launch one more little poll question, asking our audience, what do you do when you've got when you've got cluster issues? Is it a full manual recovery with do-it-yourself scripts? Is it partially automated and partially manual, for example, something like SBR? Or do you have a fully automated recovery, which would be SBR handling the application cluster aspect of recovery, and Kubernetes is programmed to have a number of pods running, so when they see pods representing Akka Cluster disappear, they know to come back. So I'll leave that open for just a minute. Hugh, you let me know when you're ready.
I'm ready whenever you're ready to go.
Okay. Right now we see a very interesting split. The largest minority is some manual, some automated. More people don't know, and that's fine. I put that option there because I don't actually know how we do this on the Lightbend website, for example. So if you're in the audience and you don't know, you're in good company. It looks like it looks like most people have some manual and some automation. So in the follow-up, you can certainly leave some of your comments in the questions tab and let us know how you do things. All right, I'm going to close this poll now. All right, so Hugh, we're back to you, and let's see what happens when Splitbrain Resolver is involved, and also to keep in mind that Splitbrain Resolver and Akka Cluster will perform all of the application level recovery that is needed to make your applications healthy, but it's not going to do things like restart Kubernetes pods, which is what we use Kubernetes for. So this is the infrastructure side of the recovery is taken over by other technologies such as Kubernetes, and but the application side of it is handled by Akka and Splitbrain Resolver.
Right. So just real quick, I shut down the cluster, and then I went into the configuration file and removed the comment on this Downing provider class. So I already done that. Then I rebuilt did the Maven to rebuild the app, and then now I'm going to start the cluster again, now with Splitbrain Resolver enabled, and with I've already got the dashboard tab up, so we'll be able to watch it. The dashboard will see when the cluster starts up. Here we go.
Which is good because it happens so quickly. I feel like we need a slow-mo version of this.
Yeah.
Hard to see. Lots of different states that can appear, and
yeah.
Akka is very quick.
So now we've got the 9 nodes running again, and if I enable the partition, so I'm going to do that again, and then what we should see, hopefully everything works. There we go. No, we don't. Darn it. I did it too soon. Sorry. I needed to wait a little bit more to let the cluster settle down.
So this is actually a good. So this would be a scenario where somebody would be launching a cluster and a network partition occurs during the launch.
Yeah.
Which is probably possible, I would presume.
Yeah, let me try it again and see if it's calmed down a little bit. Nope.
Oh, interesting.
Yeah. The demo gods are really mad at me today. I'm going to restart the cluster.
Well, to be fair, many people have started school again, and I believe that the virtual classroom concept is in force at the moment. So I don't know if anyone else has been suffering from issues with Zoom or other platforms like that, such as GoToWebinar, but I'm in that boat. So we've got a lot of questions coming in. I want to get around to some of them. Let me see.
Why don't you give me one while I'm going to let the cluster settle down for a minute. Anyone in particular?
So actually, there's a couple questions about more around what's the challenge with Windows.
It was with Windows. It was things like IP tables and network rules and enabling localhost 2. I searched and searched, and I just couldn't find the commands to do that. There were subtle differences in the way it's done on the Mac and on Linux. And I've got all 3 of those types of systems here in my office at home, Windows system on Mac and some Arch Linux systems. So I when I first set this demo up, I was trying, and I got it working on the Mac, got it working on Linux, but I just couldn't find a way to, I forget what it was. I think it was just the commands to do things. I don't think I couldn't find a way to do the rules, I think, to like block traffic between localhost 1 and 2. So I'm sure there's a way to do it. I searched like crazy though, and I Googled all over the place, and I just couldn't find anything.
Mm-hmm.
All right, I'm going to try the partition on again. Come on, be happy, be nice to me, please. There we go. There we go. All right. So it's, in a few seconds, SBR is going to kick in. It waits for. I've got it configured. There's a configured amount of time. I've got to wait for 15 seconds. And what that is 15 seconds before it will do anything. So now you see the 4 nodes in the bottom are being downed, and we're all green. And those 4 nodes have been downed, and they shut down. But basically, there were 2 Splitbrain resolvers working here. There was the Splitbrain resolver on the winning side here, the top 5, kicked in and said, well, I can't talk to those bottom 4. I'm going to wait this configured amount of time, and then I'm going to take action. So I'm on the majority side, so I'm going to just down those 4 nodes on the bottom. At the same time, pretty much in the same sequence, the SBR running on the leader node on the bottom went through the same process, and they said, all right, I'm going to wait for the figured amount of time, and then I'm going to down my 4 nodes, which will cause all 4 of those JVMs to stop. So there were 2 sets of independent actions and reactions that were occurring on both sides of the partition around, timing very close to each other, because they both see the SBR at the partition at the same time. They both wait for a configured amount of time, and then right around the same time, they're both going to kick into that to take action. But the key point is that there's, on both sides of the partition, there has to be this kind of coordinated process where the top side assumes that the bottom 4 are going to shut themselves down. The bottom 4 assumes that the top side is going to keep running, and that you have to make these assumptions. So that's where it kicked in.
Hey Hugh, would you mind would you mind doing that one more time, because it's so fast, but basically the 4-step manual process that Hugh had to go through to get the cluster, rather this is 3 steps. Otherwise, the 3 steps that Hugh would have to do manually to get at least 5 of the nodes back in the cluster and happy, Splitbrain Resolver did right away. And now, Hugh, if I'm not mistaken, what you did now is something that Kubernetes, in a Kubernetes-like environment, would be able to be automated, because Kubernetes would look at the configuration and say, oh, these folks wanted 9 Akka cluster nodes up, and we see that there's only 5 right now, so let's make some more.
Exactly. That's the beauty of Akka running on Kubernetes. Kubernetes is like the perfect orchestration environment for an Akka cluster, because you got that automated part where Kubernetes is handling things kind of at the process level, on the outside of the process, running processes, stopping processes, adding more processes, like auto scaling and so on. Whereas Akka is running on the inside of the processes. It's running inside the JVM, so it's doing things like monitoring, are JVMs actually alive? Are they behaving properly, on the inside, and making decisions about, stopping things. But Akka doesn't have any ability to reach out to the real world and say, I want to run another process. It can only control processes that are already running. So that's where that relationship between Kubernetes and Akka is so wonderful. So I manually, pretending like I'm Kubernetes or an orchestration environment, and I started up those 4 nodes again, and then I'll do the partition again. And hopefully it'll crack in half. There we go. Again, the wait time is about 15 seconds, and it's stable. It's called stable after, and what it is it's waiting for no more node changes to occur. It wants a quiet period of time, so it'll get a quiet 15 seconds, and then boom, it makes its decision, and it stops those. On the bottom side, they down themselves. On the top side, they just down the bottom side.
That's an interesting aspect that I didn't realize before. It's not that the majority on the top just needs to kill the nodes on the bottom. It's that the majority on the top needs to go through its own recognition process that these nodes have been downed, and that the bottom set of the partition also needs to recognize that it's shutting itself down too.
And take action, just shut themselves down. Right? Yeah.
So there's a couple questions that I think are timely at this part of the demo. So one of them is about what sort of things can we configure here? And I don't believe we're actually going to have time to go through and show any configurations, although Hugh and I were discussing doing a couple of videos that specifically looks at some of the things you can configure. So for example, how does SBR determine the majority, and is that configurable? The stable after period. So for a cluster of 9 nodes, if we've got 300 nodes out there, would it make more sense to have a longer stable after period? Or if it's a small cluster and you're running something on a smaller scale, can you actually have a faster stable after period, and so on?
Yeah. So in the Akka documentation, if you just do a search on, like Splitbrain, whatever, it'll come up real quick. And there's this really nice page here that covers it, the how to enable the Splitbrain Resolver, that configuration setting that I was commenting out and uncommenting. And then it goes in a nice discussion about the problem. And then the biggest decision, I think, is the strategies, where there's a number of different strategies. There's keep majority, which is what we've been talking about. There's another one called static quorum. So the behavior of which side of the partition stays up and which side of the partition goes down is impacted by these different strategies. So I don't really have time to go into static quorum, but you can look at the documentation. There's a down all, which is relatively new. We ran into this. I was actually, at the time, this is back in like 2018, I was working with a customer, big customer of ours, that was running in a Kubernetes environment, and we ran into this horrible network issue. The network was, in some segments of the Kubernetes cluster, was really, really weird, very, very unstable. It was driving the Splitbrain Resolver nuts. So one of the solutions was, right, things are so weird in the cluster, the Akka just decides, all right, I'm going to just down everybody and let Kubernetes bring us back up, and hopefully we'll be back up in a clean part of the network. So this is relatively new. So is Elise is relatively new. And then I think that's about it. There are some other ones. Keep oldest is one. So the keep oldest is pretty simple. It's a strategy where instead of keeping majority, you keep the nodes with the oldest node in it. And there's some rationale for that. And Akka does keep a close eye on which is the oldest node, because that's where cluster singletons run. Static quorum. I think those are the main ones. So from a configuration standpoint, I think by far the default, using the default is keep majority. But if for some reason you don't like that strategy, then go into documentation and look at some of the other strategies to see if it will fit your need. I think most of those other ones, though, are pretty deep. They're for very specific use cases. And I think, personally, I think keep majority is by far the best one, because mainly when you get a split, you just want to get it over with and keep going, right, and resolve it as quickly as possible. Otherwise, the only other setting is a stable after, which is right here. And and there's some documentation on how long, how big should that stable after setting be based on the number of nodes in the cluster. It's pretty modest.
So these are default recommendations.
Yeah.
Okay.
And it discusses.
So if you've got a cluster of 1,000 nodes, you should have a stable after period of 30 seconds.
Mm-hmm.
Gotcha.
But
Okay,
also
so
tell you,
folks, I think what we're getting down to here is that there's a lot of great documentation on the Akka site, and if you're a fan of Akka, you know that we take a lot of pride in our documentation on this site. I want to get to a few more questions, Hugh. We're down to the last 5 minutes or so, but there's some great questions out there that are kind of what if scenarios. So let's maybe talk a little bit about these like complex attack scenarios. So for example, is there a split brain scenario where you've got three, let's say a split brain scenario occurs where there's 3 clusters of 3, all of which cannot see each other. Is that something that can happen?
anything. My motto is,
Yeah.
if it can happen, it will happen, right?
Yeah.
So so my motto is that's going to happen at some point, right? If you have enough nodes, something bizarre is going to happen, and say we get a three-way split.
Mm-hmm.
But the logic still takes precedence. And so say we're running 9, and say we get into a situation where it's 3-3-3, right? And so it's not a majority anywhere. So there's a tiebreaker strategy. But we've got three nodes in each group that are having to independently make a decision. Should we keep running or should we down ourselves? So all 3 groups have to do that. So when it goes through this process, it'll go something like, well, there were 9 of us. Now there's 3. Well, am I going to be the majority? No, I'm going to shut myself down. So basically, in that kind of scenario, nobody's a majority, so they're all going to shut themselves down, right? Because the 3, all they know is the 3. In any group of 3, it's going to look around and go, well, there were 9 of us. Now there's 3 of us. We're not the majority. So the assumption is that the other 6 are still running. But each of the 3 groups is going to do that. So the end result is going to be that the whole cluster is going to shut down.
So if there's a 3x3 partition and you're using the strategy keep oldest, which you mentioned just a minute ago, would each so I'm going deep. This is actually my own question. Right now we see the L in 2551, and that's selected because that's the lowest
that's the leader
number. Yeah, that's sorry, L and O, so leader and
right.
oldest. And that's determined just on the lowest port number, if I remember correctly.
Yep.
So in a 3x3 partition, would each group of 3 also select a leader and oldest?
Yes.
And so the group, so 2557 through 9, the oldest there might be 2558, but it wouldn't know that 2551 was the original oldest.
But it does.
It does know that.
Yeah.
All right.
Yeah. So
That's
keep oldest. Yeah, the keep oldest, I'm pretty sure would be the 3. Say we get 3x3x3, and it, so it's like we just go by row here. It's the top row is one split, the middle row is another split, and the bottom row is another split. So all 3 are split. Each one looks and goes, well, there were 9 of us. The oldest is in my group, so I'm going to stay up, and I'm going to down the bottom 6. The other 2 groups independently go, well, there were 9 of us. There's only 3 of us now. That's an easy decision. We're the minority. We're going to shut ourselves down. The bottom row is going to go through the same process. It doesn't have the oldest, and it didn't have the oldest before the split. Doesn't matter who the oldest is of the new 3-way. It knew what the oldest was of the old 9-way.
Got it. So there's another few questions. I know we're running out of time, folks. You're welcome to stay on. I'm ready to go for longer if you're able to stay. And Hugh, I hope you are too.
Yep. Yeah.
No our rough start. I think there's some questions out there that I think are getting to the angle of, okay, well, what about outside of network partitions? And I think that we might have done ourselves a small disservice by calling this awesome tool Splitbrain Resolver, because it actually takes care of any sort of downed nodes. So Hugh, could I ask you to take down 2 nodes in the cluster, and let's watch, or just 1 or 3 or whatever, but not actually do a partition, and let's see how Splitbrain Resolver handles that one.
Yeah, so let me take down, say, 4 and 8. I'm going to kill them, right? So that's just
there's a difference between downing and killing.
Killing is I'm just killing the JVM. Down is a command that's sent to the JVM, to the node, that JVM, which does an orderly shutdown.
Okay, so this is like the server exploded.
Yeah,
and
exactly.
Okay, gotcha.
So I'm going to kill 4 and 8, and then what we should see there goes 4 and 8, they're gone. And then we see it, the red pop up, and the other ones, they go, oh, those two aren't talking anymore, right? So the leader, and I really didn't talk about the leader because where the decision's actually made. So the Splitbrain Resolver decisions are being made on this node where the L is at. Notice the L is red, meaning that the leader can still do things like SPR, but it won't add new nodes and so on. So there goes, it just downed those 2 nodes. So those nodes were unresponsive. The remaining 7 nodes were the majority, so those 2 nodes were down.
All right.
So yeah, this is a good question because this is an example where we didn't have a network issue, but a node just disappeared. It just, like the hardware broke. It just turned off, or the power went out, or something like that.
And now we have a 7-node cluster that is happily continuing to perform the work it can do, with the loss of 2 nodes that may have been containing some specific instructions. So this is where we get into cluster sharding and singletons and topics like that, right?
And the work was redistributed after the nodes were downed, and yeah, all that happens automatically in Akka. Okay.
Well, I think that those topics are subject for another video. I'm really just I have a big smile on my face at how many people wrote in some very interesting questions, and I'm afraid we won't have time to get into all of those today. So I hope we did a good enough job of laying the foundation for you. If you are a Lightbend subscriber, then you can send your questions directly through our customer portal. So we'll actually have somebody from the Akka team respond. And that's one of the cool things about having a Lightbend subscription. For those of you who have heard about Splitbrain Resolver for a while, you may not be aware that it is now part of the open source Akka toolkit. So it's part of Akka Core. And you can begin using it in earnest outside of this demo, which has obviously some special considerations in place so that we can demonstrate how things work. And basically, thank you very much for joining us and for being patient while we had a rough start. Hugh, always great to catch up, and thank you for bearing with some of these weird questions
no, they were great
of my own
questions.
and from the audience. They're great questions.
Yeah.
And I hope that you folks enjoyed this more interactive style. We hope to do more of this in the future. So if you've got some feedback about whether the interactive demo style is working best for you, you can send them to oliver@lightbend.com, and I will be happy to hear from you. So without further ado, I guess it's time to say good evening and good day to all of you. Thank you for joining us.